G'day, Bill here. This is just a short first video on the recording of the repair of my old racing car. As some of you probably know, I got pushed off the track, I think it was about 8 or 9 years ago. The car was fairly damaged. I was a bit as well, a couple of days in hospital. But it's come time that I really like to get back into racing, so I've decided to repair the old car. I'll post up some photos of the damage it sustained to the front end. Anyway, this is the chassis as it stands now. Everything's been taken off it. It's been sandblasted and then a anti-corrosion paint painted over the top of the tubes. And as you may see, I've welded the chassis to the build table, and in that case it's got a 20mm spacer, so I can get underneath it if I need to. Welding it to the table makes it stay straight, as straight as I reasonably can get it. And it just stops everything moving around when I weld bits and pieces to it, and tubes here and there and braces and so on. Because as the metal cools, the weld pool cools, that metal shrinks and it does bend things. Like if you're welding one tube to another at a 90-degree angle and you just weld one side, that tube, depending on the size of the tube and other variables, that'll pull over a couple of degrees. You can actually see it if you look carefully. So to make all these things stay put, you got to weld them down so they don't move. That being said, this car is fairly bent. To get this front upright straight vertically, I had to cut this tube, which is attached to this tube. So it is actually fairly bent, and I have been asked, and I ask myself occasionally, is it really worth fixing? Because I have another car, I'll show you that shortly, which is probably more complete, or the chassis is more complete. It would probably require more work to get it going. It's a Malik Mark 31 from the UK. We built the chassis here, licence built, and it will be a faster car. So why am I continuing with this one? Why do I want to fix it? Simply because I've had it just over 30 years now. It's my old mate. It's not the fastest. Still, it was fairly quick in its day, but I just like to keep it. You know, I've had it more than half my life now, and I do want it back. Yeah, a lot of people liked it, so do I. Anyway, I'll explain what this bit is in a moment. Okay, here's that chassis I was talking about, the Malik 31. There it is. It's quite a bit stiffer than the old car. The old car is a little bit flexible, and I'm going to improve on that. What I decided to do, because the wheelbase on the old car was quite short, 82.5 inches, which did make it very, very light. It was one of the lightest cars out there, and that was a very good thing for, you know, straight line speed and cornering and braking and so on. It was a wee bit flexible. This chassis was probably in the order of 3 to 4 times stiffer. And the Maliks have been developed over 40 plus years, and they're a very, very good package. This will hit the track at some point. I'm not 100% sure which engine it will have in it. It'll be one of two. Quite possibly a turbocharged Suzuki G13B. I've got the same engine, though naturally aspirated, in the old car. It went really well, and in the time I've had off the track, I figured out how to get more power out of it, which is always a very good thing. Now, okay, back to this chassis. What I'm going to do, I decided to make the car a little bit longer so it's a bit less twitchy. A common wheelbase is about 90 to 92 inches. I think this Malik's about 90 from memory, I can't remember, something like that. The repairs to the old car will make it have a 92-inch wheelbase, so I'll explain that when I go back to the other chassis rather. Anyway, now the reason that bit of framework was welded to the table in front of the car, what I've done, I've recreated this part of the Mallet chassis in front of the old one. And from that part, I can start building the rest of it. One of the best bits of the Mallet chassis is the higher chassis tubes at that point. It's called a cathedral, I believe. I'm going to do that as well, because this chassis was, it's basically the same as a Mark 29. All the tubes are in reasonably similar places, but all they did, that used to be level with the upper chassis tube, so you just grabbed it, moved it up to there, and it improved the torsional rigidity of the chassis by about 50%. For really very little extra weight, a little bit higher centre of gravity, but they did prove with lap times it was a very good thing. Now the problem is adapting this to the old car is this part, if to get the wheelbase I want, is way closer to this bit because of the rest of the chassis is different. The driver sits further back in this one, the rear axle's a bit further back. That gives them a fair bit more room here that I just don't have. So the repairs to the old chassis will make it look a little ugly, but speed counts, I don't really care how it looks. I won't be duplicating the whole thing. That part there probably won't be there. I'll just be doing the single point up to the top, that bit there. Time will tell. The other reason is I can just reuse the suspension that's already built for this one. I don't have to build new suspension for the old one. Eventually, of course, I'll have to make more for this one or swap it back over, but so be it. Gets one car on the track quicker. It uses a shortened Escort Mark II quick rack. I've got that tucked away somewhere. I'll have to dig that up. Again, I'll just make that bolt straight on. One thing they have got, I forgot, they've got a removable tube that goes from here to here on the chassis, so I've got to duplicate that. I'll do it a little bit differently so it's a bit easier to use. While I'm here, this is a replica of my dad's old Mark I Cortina. What do you call it? I think it was sports sedan closed, something like that anyway. Originally, his car came with a 1500 Kent engine, I believe, and it was okay for what it was, and especially at the time, I suppose, but he definitely wanted to go a lot faster. So what he did, he put a Ford 302 Windsor into it. And when I mean into it, I really mean into it. The engine actually sits inside the car. Anyway, long story, I won't bore you with. There's the engine. I decided to build a replica of it. Most of that engine's from the original, so I've kept it all as close to the original as I could. The original didn't have a roll cage, which made it kind of terrifyingly flexible. So this one's got about 25 metres of roll cage tube in it. A mate of mine did all the 99.9% of the fabrication because he's a lot better than I am. Anyway, hopefully I'll get that track back on the track perhaps later this year or next year. Time will tell. Okay, this is what the repaired old chassis will look like. No, just kidding, of course not. That's our tractor lawnmower thing. Okay, back to here. That's that bottom arrangement of square tubes for the lower suspension part of the Mallet chassis. As you can see here, got 92, 93, 94, that's inches from the centre line of the rear axle. And that mark there is where the front axle centre line will be. So I put those marks on the table. I measured from the rear as accurately as I could, just to see mentally what the joining chassis tubes will be like. Yeah, the angles might be a wee bit ugly, but I can cover it up with sheet metal and pretend it's not so bad. For example, I've got to have a tube going like that, and it's a fair angle, but so be it. Another one down like that. I've cut the front off the old chassis, as you can see. I've just welded this tube in because we need that bit, and I'll build it up from there. The top of the chassis is pleasantly quite close to that of the Mallet. It's close enough. Again, I'm not too worried about that because as long as the suspension points are the same in 3D space, the chassis being a wee bit bent doesn't matter so much. I mean, if I was gonna go, racing for sheep stations, as they say, cattle stations, whatever it is, yeah, I would. But this is an old car, like I say, it is fairly bent. I'm not too worried about it because all the suspension points will be spot on. So anyway, as time goes by, I'll just show what I'm doing to join it all up. I'm going to make sure that the new front end sticks quite well. So I'll just grab this here to join the new chassis tube onto there. There's not much metal there, and I can just add more and more weld, but that, okay, as I said, it pulls things around, not so good. So I'm actually going to weld in just a little bit of plate. Camera work well. Weld in a little bit of plate there on both sides, and that'll make it quite strong. For here, again, I could do a butt weld, but I just like it a little bit stronger. So I've actually got some 16mm tube, which just fits very neatly up into there. I can drill some holes all around, make the tube about that long, and fill in, fuse weld, no filler really needed, fuse that 16mm a bit inside there so it's basically as strong, probably stronger than the original metal. Then I can slide another 20mm tube, that's what all this is, over the top, and it'll finish around about there, I think. And then we go from there, making it up as I go along. For what it's worth, that's the old engine, Suzuki G13B. The rules back in the day required to have several restrictions, as they were called back then, because this was intended, as it was back then, as a parity engine. Parity being about the same horsepower as the older two valves that we used to use. Commonly used was Toyota Corolla 3K, bought out, I think it was 4mm, to take it from 1200 to I think 1298 cc's. They made about 135 horsepower for most of them, plus or minus a bit for whoever built it. The Datsun A12s, again about the same. The better ones putting out up around 150 odd. What else they use? Nissan Pulsar, I think it was. Golf. A lot of the serious guys use Golf engines, turning them to lots of revs. They made a good 150 odd horsepower. Anyway, this one, the New South Wales Sports 1300 or Clubman, I think it was back then, decided that, and quite rightly so, if we applied the same performance improving techniques to this engine as we did to the two valve engines, we could get a lot more power out of this thing and immediately put the two valve ones at the back of the field, and nobody wanted that. Well, I wouldn't actually mind winning a lot, but anyway, and it was really fair enough. So they spent a lot of time on a dyno fiddling with camshafts and compression and bits and pieces, and they came up with a set of camshafts off the shelf from Thai camshafts in Brisbane. I forget the actual spec of it. They're about, I think about 270 degrees odd duration, 355 thou inches lift, and they're built for a hydraulic bucket type thing like the Suzuki has. It doesn't have rockers. It's just the typical cam-on bucket on top of the valve system that a lot of twin cams have, but the buckets were hydraulic, so they were self-adjusting. And that's how the thing was set up. So the cams have got hydraulic, what they call hydraulic opening and closing ramps to make the little hydraulic system inside the bucket do its thing. And basically that means the opening ramp smacks into the bucket fairly hard, so that the, I don't know a lot about these things unfortunately, the little bleed off valve in the bucket doesn't bleed off. It just bang, it shuts immediately and the valve pushes the valve down and away it goes. Similarly with the closing thing, the closing ramp. We're not using hydraulic buckets in this one. We're using buckets, they're 31mm diameter, out of a Toyota Echo, or I think Yaris these days, Yaris, where it is. They're 31mm as well, but they're purely mechanical. They've got a varying length post in the centre that sits between the top of the bucket and the top of the valve, and you just order whichever bucket you need, which that little post thing varies in length to get the valve clearance that you want. Because the hydraulic opening and closing ramps are fairly aggressive compared to a mechanical type cam where there's no hydraulics, we actually have to run more valve clearance to avoid the nasty bit of that. So we have noticed, well, this is years ago, where we had smaller valve clearances, that clearance did move around more than the valve clearances which are open more. So from memory, it's been a long time since I checked, about half the valve clearances in this are smaller and moving around, the other half are wider and not moving around. So that's one of the things I've got to do to get it back running nicely again. The other thing I'm going to do, back to what I was talking about, 135 horsepower. We did actually build a full-on race engine where the second car to put the Suzuki in. The first one was Kevin Leggett down in Sydney, and he's one of the chaps that did all the work on making the bits and pieces for the parity engine. Parity engine has, I think, about 10.5 to 1 compression. The camshafts are about 270 degrees, 355 thou lift. And what else? To get that compression ratio, there's a minimum distance between the top of the head without the cam cover and the bottom of the head. Because if you start shaving off lots off the head, you can get more compression. If you have a minimum thickness, then that makes it that much more difficult to get more compression, because you're also not allowed to add anything to the combustion chamber. So they all end up about 10.5 to 1 maximum odd compression. You can't have the piston sticking out of the top of the block at all, so no big crowns on the top of the piston to increase the compression ratio, which I'm not a fan of really anyway. Maybe a small crown, but that's about it. Yeah, so the pistons on these things are all flat top with just little cutouts for the valves to clear and the pistons up near top dead centre. And the other thing was an 8,000 RPM rev limit, which is pretty close to standard. The standard engines in Australia made 100 horsepower. The parity engine was 135 on a reasonably accurate dyno, I believe. We did a lot of work on reducing the various frictional losses inside the engine. I won't go into that, but the last time it was on a dyno, it made 153 horsepower at the crank, so that's quite a bit more than the parity engine. Since then, we made some small changes to the inlet ports on the head. It hasn't been on the dyno since then, but I can guarantee it would have made a little bit more. And what I'm going to do for this engine when it goes back in is the ignition system, which runs on a good old-fashioned distributor there. That's going to go, and as you can see, I'm going to use coil on plug, 4 of those things. Now, one of the reasons why I'm going to do that is the ignition system on this, as it comes from the factory, is about as bad as you can get it, because have a look. The cams, of course, driven by the crankshaft down here with the rubber belt. That section of the rubber belt will have harmonics at certain revs, and as it flaps around, it will advance and retard the cam very slightly, not much, but whatever it does move, because the cam runs at half engine speed, say, just pick a figure, 1 degree here, that's equivalent to 2 degrees on the crankshaft, and that can make a difference. And again, in that short bit of rubber belt there, rubber cam belt, again, it will have harmonic problems. Because it's quite short, I suspect it would be at very high revs, way above what we run at, or allowed to run at, because this still only runs to 8,000. But still, it's there. There may be lesser second and third harmonics, which at lower frequencies, which might affect it. And that might also move the exhaust cam, advance and retard it a wee bit. Then we have the length of the camshaft itself. Probably not much, again. I'm not quite sure how you'd measure it, but with the drag of the cam, because it's driven at one end, and all the lobes create friction, they'll actually twist the camshaft, retard it slightly. Basically very little at the front and increasing as it goes back. So the last cam lobe, which is what's on the inlet side, so the last number 8 cam lobe on the inlet will be slightly retarded and increasingly so as the revs build up. Again, not much, because it's not a very aggressive cam, it's actually quite small. Not much bigger than road cams actually, but more lift though. Anyway, all those combined together, so the timing wobbles around, and as the revs build up gets a little bit more retarded as time goes by. That isn't necessarily a bad thing, retarding the timing as the revs build up. Plenty of engines do that, but I'd like to make the decision myself. So what I'm going to do, it's still legal in the class rules. Before I forget, the class rules actually don't exist anymore because of many changes in the last 8 or 9 or 10 years, whatever it is. So although I could build another Screamer engine, which I did, so I was going to tell you about that, I won't do it. I'll keep it to the rules that don't exist anymore to make it, fair for everyone else. Anyway, I'm going to replace the distributor with, air. I'm actually going to block up the hole and use a very small computer-controlled engine management computer designed in Australia. It's called Speeduino. It's based on the old Arduino 2560 Mega, I think it's called. A small board that plugs into the top. A bloke named Josh, something or other from Melbourne, came up with it, and it will just control the spark. I'll have to put a crank angle sensor down here, weld that onto the sump. That's pretty easy to do. I've got one tucked away up in the shelves. And that will sense crank position and fire the ignition coils at the right time. 1 and 4 together at around top dead center, and 2 and 3 together when they're up around top dead center. And it'll be much better controlled. So there'll be a tiny bit of power in that, another 1 or 2 or so. The other thing it can do, I've actually got enough code in the thing's coding ability and inputs and outputs in the Speeduino to control variable cam timing in some engines. So we're going to use that output to control a Davies Craig electric water pump. That also will free up a little bit of horsepower, depending on which way you look at it. On an engine dyno, when you run an engine at constant revs, the water pump doesn't actually use a great deal of power because the water is circulating. It does, however, burn up a bit of power when you're accelerating the engine because you have to move the mass of that water, and it's pretty substantial. So in a racing car, of course, the engine is basically accelerating all the time, so that water pump's sucking a wee bit of power all the time. I'll be running the engine on a total loss system, so it'll just be a battery, no alternator, because there's really no room to put an alternator in anyway. Well, I have actually worked out how to do it, where the distributor used to go. Believe it or not, with a radio control aircraft model brushless DC motor acting as a generator. It's all possible. Don't know, I might do it, might not. I'll have to wait and see. Anyway, the water pump will be controlled by the Speeduino ECU, and it will use what was the VVT, variable valve timing output coding and output pins on the board to control via pulse width modulation the electric water pump. So you can set the thing up so it keeps the water at a constant or fairly constant temperature. It'll be a little window of, 2 or 3 degrees Celsius, probably between 75 and 80 degrees, or I'll keep the water temperature. If the water temperature gets a bit below that, the pump will slow down, giving more time for the water in the radiator and more time for the water in the engine to heat up, and that will increase the temperature. Same as when your car's sitting still, that's when it runs hot. It's when it's moving on the highway, lots of air coming through the radiator. It typically runs coolest, that's unless your car's broken or something. Same deal with this. So if it's running a bit cool, I slow the pump down, running a bit hot, speed the pump up proportionally, and that will work. So we can set the thing up, of course, so from a cold start, the pump will run at about, I don't know, pick a figure, half speed or something, just to keep it ticking over, and it'll warm up from there. The other thing the engine's got, being a racing engine, it's dry sump, because the old car used to get up to, I think, about 2.1, 2.2 Gs at high speed, lateral cornering. You have to run a dry sump system, absolutely have to. Could run a wet sump, but you need an awfully deep sump, and that kind of defeats the purpose with half the engine sticking out of the bonnet of the car. So they run dry sump systems, and you also get a little bit more power as well from having a partial vacuum in the crankcase. Being a dry sump system gives you the ability to cool the oil as well. Most cars run a small radiator with extra pipes and so on. You end up having a scavenge tank where the oil sits, usually out the front here or off to the side or something like that. So there's an oil line coming from the tank to the engine. A lot of people run a pump on the engine, on the side of the engine. So they have a line going from the tank to the pump to the engine, through the engine, gets picked up by the scavenge side of things, another one or two lines there through the scavenge pump, then another line to the oil cooler, little radiator, then the oil cooler back to the scavenge tank. That's a lot of lines, a lot of things to go wrong. When I did the big rebuild, we did the big rebuild on this in 2007, I decided to use a water-to-oil heat exchanger made by Satrab. And it sat in the the water line to the engine from the radiator. It was out the front, the inlet and outlet was over here. So in between that line there and there, to and from the engine, was looked like a hot dog muffler sort of thing, a resonator muffler sitting in there. And that had the oil line coming in and out. That exchanged its heat of the oil into the water to keep the oil cool. And it worked really, really well. But I thought of a simpler way. This actually has a WRX oil cooler, heat exchanger, water to oil heat exchanger. I figured since the WRX is a 2-litre turbo, would probably be more than enough, adequate enough rather, to cool the oil for a 1300 naturally aspirated. To get the water in and out of it, there's a little fitting on the end of the water pump there that a very good fabricator mate of mine did. That's the pressure side, and it runs around to the one side of the heat exchanger there, and that's coming out of it, and that goes back into the water coming into the engine. And that has worked very, very well in the past. Keeps everything at the right temperature, warms it up quicker when it's cold, and it's quite light. But the big thing is, it reduces a huge number of oil lines. The other thing we do, we're using the original oil pump in there, the front cover, and we feed the oil straight into it from the oil tank. The oil tank on the old car sits about here. It's got a line that comes out straight into the engine, goes through the engine. I don't know if you can see it under here. Yeah, that's it there. We've only got one pickup in the sump, but it does seem to work quite well. That's the scavenge line. Into the scavenge pump, there's no pressure pump there. The return line comes from here, goes into the scavenge tank about here. So we've actually just got 3 oil lines in this thing. Scavenge tank to the oil pump, through the engine, scavenge line, hose, whatever it is, up to the scavenge pump, back to the tank. And that's it, 3 lines. So very light, very simple. And as the old saying is, if it's not on the car, it can't break and it doesn't weigh anything. So with all that, I'm hoping to crack 160 horsepower out of it. Maybe not, but it was always one of the more powerful engines out there, so hopefully I can squeeze a bit more out of it. That's all I'll do right now. Oh, before I forget, all of that pile of junk in there. That's all the bits and pieces off the old chassis, you know, panels and bits and pieces. That's the old ignition system, little optical thing. The old instrument panel. Oh yeah, the fuel tank, that'll go back in. It's still a good thing. What else we got? The tail brake lights, only require brake lights on these things. And other bits and pieces. I've decided to make a few changes to the internal paneling to make it a bit simpler and lighter as well. Anyway, that's about it for now. I don't know how quickly all this is going to happen, but I'll try and get a reasonable chassis going before the end of the year. Thanks for watching. Please subscribe and give me a thumbs up, because hopefully I'll get to the point where I'll be able to get enough subscribers to make a couple of dollars out of this. It all helps. Anyway, catch you later. Bye.